Welcome to Geometry Pre-AP. Today we're going to do a lesson on trapezoids and kites. Take a minute to just pause the video and write down the definitions of all these things that I have circled here. You will need those, and then get the essential questions here and write those down also. Okay, so the parts of a trapezoid. You might want to pause the video and write down this whole entire page, and then I'll go over it in a second. Okay, so the legs of the trapezoid are the two sides that are not parallel, and the bases are the sides that are parallel. The base angles are the angles attached, and they come in pairs. So this is a pair of base angles, and this is a different pair of base angles, and so they come in two pairs. They're not base angles going this way. That's not base angles. It's going with the attached with the bases, okay? An isosceles trapezoid is a trapezoid where the legs are congruent. So make sure you make a note of that. Just like an isosceles triangle has legs congruent. And finally, the mid-segment of a trapezoid connects the midpoints of the legs. And so you'll need this picture also. Okay, so we have some theorems to highlight. This one says that if you have an isosceles trapezoid with the bases, then all the base angles are congruent. Okay. And this one also says if you have an isosceles trapezoid, then the diagonals are congruent. Now, what other kind of figure has congruent diagonals? And that would be a rectangle. But what's the difference? This is a trapezoid with congruent legs, and a rectangle is a parallelogram. So there's a difference between those two, but know that they both have congruent diagonals. Alright, so take a second to find the missing angles for these figures. These sides were supposed to be marked parallel. The arrows aren't showing up real good. So pause your video and find that. I'll do this first one here. So this is a isosceles trapezoid, then the base angle is congruent, so this is 50 and that's 50, and then due to same side interior angles, this is 130 degrees, and this is 130 degrees. So pause the video and do that one real quick. Alright, and if you have questions on that one, come back and ask me in class. Alright, so here's a mid-segment theorem. We had a mid-segment in a triangle, now we have a mid-segment in a trapezoid. And so the mid-segment, Mn, is equal to 1/2 the sum of the bases. I think of it as an average of the bases. Because if you add the bases and divide by 2, that is equal to the mid-segment. So I can put this 1/2 here, or I can just cancel it and put this over 2 plus 1, and have a nice proportion going on. I think that's the better way to remember it right there. Okay, and so here we have a trapezoid, and it says QR is a mid-segment, and we know that the mid-segment is equal to 1/2 the sum of the bases. Remember, it's an average, and so we know that QR is equal to 1/2 ln plus bn. So that's the mid-segment there. So when we substitute our information in here, then once we have our information substituted in here, we can simplify. So we add the 8 to the -2, we get -2, and then we distribute, which I get 2x minus 2, and then I finish with my solving, and so I get x is equal to 3. Of course, I could also ask you for the length of those pieces. So now, do the same thing here and find the value of x for this one. On the test, I'll ask you to find the length of the missing pieces also. Okay. So if we want to prove a figure is a trapezoid or check to see if it's an isosceles trapezoid, remember trapezoid has one pair of parallel sides. So let's give some letters here for this figure. So T, R, A, P. So we really want to check. You can probably see that the legs are probably the TP and the RA. So let's go with TR. So the slope for TR is 1 down and 1, 2, 3 over. So slope is -1/3. The slope for PA is 1, 2, 3 down and 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 3 down and 9 to the right, which is -1/3. So PA and TR have a slope equal to -1/3. That means they're parallel. So PA is parallel to TR. We can see that TP and RA are not parallel, but let's go ahead and do their slopes anyway. So 1, 2, 1, 2, 3, 4. So slope here is 2 up, 4 to the right. Slope of RA is 1, 2, 3. The slope here is negative 4 over 2. All right, which this is 1/2, and this is negative 2 over 1. So we can see that TP is not parallel to RA. And so since you have one side, that's a parallelogram. But let's check and see if it's isosceles. Sorry, not parallel, it's a trapezoid. Let's check and see if it's a isosceles trapezoid. So if my sides were 2 and 4, so that means TP squared is equal to 2 squared plus 4 squared. So TP squared is equal to 20. And so then TP is equal to 2 square root of 5. We got RA squared is equal to 4 squared plus 2 squared also. So RA is going to equal to 2 square root of 5 also. And so since TP is equal to RA, oops, I don't know what that was. Get back in here. So since those are equal, we know that oops, we have the legs are congruent. So we have an isosceles trapezoid. All right. So just like when we did the other figures, don't forget to do that one. All right. So a kite. A kite is a quadrilateral with 2 pairs of consecutive sides congruent and no opposite sides congruent. So that's kind of the tricky part for this one. So 2 pairs of sides congruent, opposite sides not congruent. All right. So the theorem we have for the kite in this book is that the diagonals are perpendicular. Now that's also true in what other figure? That is true in a rhombus and a square. So how do you know if it's a kite or one of these figures? Well, remember that opposite sides must be congruent in a parallelogram, and these don't have opposite sides congruent. So there's the difference between the rhombus square and the kite. Now, the book does not list this one, but most books do. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So it's the pair that's located between the two non-congruent sides. So this pair here and this pair here in blue. Make sure you remember that. That's a property you need to know. Later in this video, I'm going to share with you the rest of the properties so that you can apply them also. Not every book has all the properties. Many of them can be proven using theorems and postulates that we know already, but I want to go through all of them. Okay, so if we want to find the angles 1, 2, and 3 of the kite, then we're going to look here. We know that this is a right angle because it's a kite and those are perpendicular. So we can easily know that angle 1 is equal to 9 because the diagonals of the kite are perpendicular. Now if I know this is 52, I know there's 90 degrees left. When I subtract, I'll find the missing angle. So angle 2 is going to equal to 38 degrees. Okay? And we know that since we have a kite here and this side are congruent and this side are congruent, and we know this is reflexive property, we know that this angle here and this angle here have to be the same, which makes angle 3 also equal to 52 degrees. Okay? Now, remember I told you that the angles are congruent, so in this case here, we know that we have 360 degrees in a kite, minus 140 degrees. That leaves me 220 degrees left. And since these are the two congruent angles, we divide this by 2, and it leaves me 110 degrees. Now if we look at this figure, take a minute, see if you can solve this figure, and we'll talk about that. When you're done with this figure, you should get angle G. The measuring angle G should equal 80 degrees. If you don't get that, make sure you ask a question. Alright, so because the diagonals of this kite are perpendicular, you need to be able to do this on your homework and on your test. I'm going to ask this kind of question. So we want to find the length of this side, and this side. So if we look at this first one, we got 4 squared plus 6 squared equals c squared. So that's 16 plus 36 equals c squared. 52 is equal to c squared, so c is equal to the square root of 52, which is going to be 2 squared of 13. So this is 2 squared of 13. This is 2 squared of 13. We go to the other side, that's 6 squared plus 12 squared equals c squared. That's 36 plus 144 equals c squared. 180 equals c squared, square root at the end. When you simplify this one, you should get 6 square root of 5. That's your missing link. So this is 6 square root of 5. And this is 6 square root of 5. So make sure you understand that the diagonals are perpendicular, that you can find the missing sides, or find any of the missing parts of the diagonal. Alright, so let's go over the properties of a kite again. So these sides are congruent. They give you the theorem that says they are perpendicular. And I told you the side between the non-congruent sides is congruent. So this is congruent to this. So let's talk about the other properties real quick. If you look at the kite itself, we know that the triangle here and the triangle here are actually congruent by side, side, side because of a reflexive property. So if they're congruent by side, 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 that means that this angle right here is congruent to this angle, and that means this angle is congruent to this angle. So we have one pair of non-congruent angles bisected. And it's the side that's located between the congruent sides. The angle is located between two congruent sides. All right. Another thing is that if we look here, okay, and I look specifically at this triangle here and this triangle here, we got angle, angle, side going on. And so that means this is congruent to itself, this is congruent to itself, and that one is congruent to that one. So that means this diagonal and this diagonal are bisected. So that means the diagonal through the congruent angles is bisected. And that is all the properties you have of a kite. All right. And so, just to give you here, you can copy down the relationship of all the Carlyles. It kind of shows you all the different ones and how they all go together. It's good to know the processes and know how they go together. And that wraps up the end of our lesson.